Hello everyone, my name is Jung, Chief Engineer of Research Institute at SB Engineering. I'm glad to have a chance to introduce SBarch Composite Girder to all the members here. Let's start presentation. This presentation will be presented in order to SBarch's technical concept, modularization design, structural performance verification, applications and fabrication procedures, so on. In general, we know that the plate girder's sectional efficiency is excellent. However, we use box or tube type girders because of convenient maintenance and safe construction. Now, as you can see at this page, if tube section and plate section is combined and having arching effect, it will have more sectional efficiency by composition. And the section has tube shape, what is strong at shear stress and distortion. Middle section has almost similar to plate section, what is most strong at having structural efficiency. Inside of tube, SBarch has concrete infill with certain thickness to prevent buckling at middle flange. Because of this, steel stiffener is not necessary, so that finally we can reduce steel weight. And also, high depth ratio of concrete makes good performance at vibration of bridge. As a result, SBarch composite girder can reduce 30% of steel weight compared to general steel box girder. In case of continuous bridge, it is possible to design with up to 120 meters. At the simple span, the strength of girder is improved by arch effect. At the continuous span, as placing concrete in the box bottom of support area where compression force is acting, it becomes a double composite girder to increase efficiency. The design of SBarch is modularized by specific program so that we can provide accurate design with short period. Recently, we are actively preparing for BIM-based design. Next is about structural performance verification. Many tests were performed for the behavior analysis and performance verification of SBarch composite girder. In 2009, the behavior was verified through the 20-meter reduced model test. In 2011, performance was verified through the first real bridge. In 2014, a real-scale test of a 60 meters railway bridge was verified its performance. In 2015, 105 meters girder lifting test proved the construction safety of long-span girder. The following is the application performance of the SBarch composite girder. 77 road bridges have been completed. 35 railway bridges have been completed. These are the curved bridges. Layered bridges with 35-meter height. This bridge was built in mountainous area and was constructed with IRM methods due to over 60 meters from ground. For the last, I will explain the process of manufacturing the SBarch composite girder. First, we make girders at the factory, transport to the site in blocks, assemble at the site, and erect it on a pier. After erection, the construction of bridge is completed by placing concrete inside of the girder and construct deck slab. Thank you very much for your attention. The next, you will watch the construction video of SBarch composite girder. I think it will more helpful to understand the SBarch girder.
Suyong River Bridge was designed with the PCT composite girder in 2014. But an accident was occurred at other construction site which used PCT method. So, Korean Expressway Corporation and KCC were searching for alternative method of PCT. However, it was very hard to find appropriate method for 80-meter long span bridge for the limitation of schedule and construction method. But after Haedong Bridge Incorporated, which has SBarch method that is excellent for long span, was selected as alternative designer, construction site was opened at 2016 October, and temporary assembly for 9 spans was finished in 3 months. In conclusion, 3 months was shortened by changing structural design. Deficit was expected for KCC when using PCT method. But by changing the method from PCT to SBarch, profit from shortening construction period and reducing expense was occurred. The steel plates used for SBarch are carefully supervised. Upon Korean industrial standard and self-quality control criteria, and accurately cut by computer following shop drawing to make large and small member. The cut plates are welded with lateral and horizontal stiffener to avoid buckling. Then each section is installed at the right place, and small and large assembly are proceeded with tag welding. Welding of SBarch composite girder is done by skilled engineers who pass the WPQ. Completed block is stored in open storage area after check the perfection of in-place assembly by temporary assembly and disassembly. Painting procedure of SBarch composite girder is done under Korean standard, which is considered appropriate paints for each process and sufficient interval of process. After final inspection of director, the completed girder are carried by trailer following the sequence of assembly. Support and rubber band are used to prevent damage of surface. Field assembly of SBarch is done considering assembly order and camber. Girder is handled carefully to prevent being damaged during assembly. In-place welding is proceeded with protection facilities, which based on factory weld standard. SBarch composite girder can be erected span by span without temporary bent for the reason that it has been reduced 30% steel usage compared to steel box girder. Installed girders following erection planning can be connected safely with bolt fastening in the air. Quality of arch concrete is strictly managed by covering curing blanket. After placing concrete inside the girder up to stupor, making the masonry joint, and pasturing.